By now we have learned how a capacitor stores electrical energy between the two plates of the capacitor in the electric field, and the electric field I had derived in my previous lecture. E was equal to sigma by epsilon naught. Sigma was surface charge density, how much charge is stored per unit area of the plate. Also we have derived capacitors in series. The expression was like this. Also derived capacitors in parallel. The expression was like this. Also energy stored in a capacitor, capital U, half CV square. Energy density, small u, half epsilon naught E square. And if the capacitor is filled with a dielectric, that is an insulator, then the energy density was half epsilon E square, where epsilon was the permittivity of the dielectric. Now a common potential. Let the two capacitors are connected in parallel, and you know what is a parallel combination, it was already explained. Let C1, capacitance of one capacitor, charged to a potential V1, and C2, capacitance of second capacitor, charged to potential V2. And since charge stored Q is equal to CV, which was derived previously, therefore using this formula, charge stored in the first capacitor will be using this formula, C1 V1, and charge stored in the second capacitor will be using the same formula, C2 V2. So the total charge before they are connected in parallel, that is before sharing of charges takes place, the total charge is equal to this plus this, that is C1 V1, C2 V2 plus. Now they are connected in parallel. Let V is equal to common potential. Now the charge on the first capacitor is equal to C1V, because now the potential is V after sharing of the charges, and charge on the second capacitor is C2V. If no charge is lost in the process, now the total charge is equal to this plus this, that is C1V plus C2V. So from equation 1 and 2, C1V plus C2V is equal to C1V1 plus C2V2, or taking V common, we have left with C1 plus C2 within the bracket, the same thing as this. Therefore C1 plus C2 was multiplied here, goes to the other side, is divided. So the common potential is C1V1 plus C2V2 divided by C1 plus C2. Thank you.